So we've had a lot of experience solving different types of equations, and now in this chapter we've had a lot of experience with different radicals, square roots, cube roots, etc. So we're going to be solving equations, but we're going to be solving equations that involve some sort of radical, a square root, a cube root, etc. So that's all that a radical equation means, just some sort of equation involving a radical expression. So here's a step-by-step that we're going to go through. So first step is you need to isolate the radical expression. Okay, so isolate the radical on one side of the equation. Left, right, doesn't matter, but that radical has to be completely isolated on one side of the equation. Then to get rid of it, you're going to raise both sides of the equation to the power of the index. So if there's a square root, you square both sides. If there's a cube root, you cube both sides. You're doing whatever you need to do to get rid of that radical expression. And then you just kind of solve it like normal, because then you'll just have a polynomial equation, and you'll just solve it. And then very, very important third step is to check your solution, because you may have done everything absolutely right, like you didn't make any math errors at all, but it's possible that you could have what we call an extraneous solution. And that's something that just for some reason does not satisfy the original equation. You did everything right, none of your math was wrong, just for some reason the numbers don't actually work out. So let's look at some examples. First example, okay, so step one was to isolate the radical. So here's my radical. I've got to get rid of that -1 to make sure it's all by itself. So I'm going to start by adding 1 to both sides of the equation. So now I have square root of y minus 2 all by itself is equal to 6. Okay, so that was step one. Now my radical is isolated. Step two is to raise both sides to the power of the index. Since the square root, my index is just 2, which we never write, but it is 2. So I am going to square both sides. Square this, square that. So on the left, when I square it, it cancels with the square root, and I just have a y minus 2 equals, and then 6 squared is 36. Okay, so I can solve this. That's the step 3, is just to solve like normal. So I'm going to add this 2 to both sides, and I end up with y equals 38. Okay, so we're not going to box it up and call it our final answer until we actually check. So if we sub in a 38 here, so 38 minus 2 in a square root minus 1. So square root of 38 minus 2 is the square root of 36, which is 6, minus 1. That does, in fact, equal 5. Okay, so it works. So we can box it up and call it our final answer. Next one. This one we've got 2 different radical expressions. So this will happen every once in a while where you can't completely isolate it. So what I usually recommend is that you take the more complicated one and make sure that one's isolated. So this one's more complicated, this one's a little bit more simple. So we're still going to do the same steps. We're still going to square both sides. But with these ones, when you're involving 2 radicals, it's going to involve kind of a double squaring step. So you'll see what I mean once we get this all squared out. Square this one. Because the big square root and we're squaring the whole thing, we just end up with x minus 12. This one, since we have like 2 disconnected pieces, squaring actually means we have to write it out twice, and we're going to end up foiling. So we've got 2 minus root x times 2 minus root x. So again, the difference between these 2 sides is here the square root went over the whole thing. Here we have 2 isolated, distinct pieces. So I'm going to ignore this left-hand side for a second, just leave it as x minus 12. And then over here I can FOIL. So 2 times 2 is 4. 2 times negative root x is negative 2 root x. Negative root x times 2, another negative 2 root x. And then negative root x times negative root x, that actually ends up being a positive x. Negative times negative makes it positive. Root x times root x, when I multiply the 2 square roots together, I just end up with x. Okay, so let's keep simplifying. First thing is I could subtract an x from both sides of the equation, and they actually end up canceling, which is nice. And then I've got this negative 12 on the left, and I've got 4. This simplifies to negative 4 root x. So now I'm kind of starting my steps over. I'm going to get to the point where I can isolate that root x again. So I will subtract this 4 from both sides. I'm going to move my answer up here. So negative 12 minus 4 is negative 16 equals negative 4 root x. So next, to isolate it completely, I'm going to divide both sides by this negative 4. I get 4 on the left, I have root x still on the right. So now I can go through my second step, square both sides of the equation. So I'm going to square this root x, I'm going to square this 2. So I end up with 16 equals x. So remember, we're not going to call it our final answer until we actually check. So if I plug in 16 here, 16 minus 12. So the right-hand side ends up being the square root of 4, which is 2. On the right, I'm sorry, that was the left. On the right, I've got 2 minus the square root of 16. 2 minus 4, which is negative 2. So the left-hand side does not equal the right-hand side. This actually ends up being an extraneous solution. We didn't do any of the math right, or any of the math wrong, I promise. It's just sometimes with these square roots, the left-hand side and the right-hand side don't end up the same. So that's what we call an extraneous solution. So you would still do everything, write all the work down, you just cross it off at the end. So don't like erase it or anything. This shows me that you checked your answer and discovered that it was in fact extraneous. And remember, your calculator can do the check for you too. Okay, let's do example 2. Isolate the radical expression. So I'm going to subtract 5 from both sides. And so remember, what this 1/3 power means is that it's a cube root. So I'm going to write it like that. And I've got a negative 5 over here on the right. So second step says to raise to the power of the index. So the index is 3, which means I'm going to cube both sides. So when I cube the left, it just leaves me with that 3y plus 1. And then when I multiply negative 5 times negative 5 times negative 5, I get negative 125. Okay, now I'm going to solve the equation. Subtract 1 from both sides. I'm going to move my work over here. 3y equals, it's a negative 126. And divide both sides by 3. Okay, so y equals, I end up with a negative 42. And I'm going to double check. So I've got 3 times negative 42 plus 1. Raise that to the 1/3 power. So this ends up being a negative 126 plus 1 is a negative 125. Raise that to the 1/3 power. The cube root of negative 125 is negative 5. So then plus 5 does in fact give us 0, just like we have here. So that one works. Remember, cube roots are allowed to be negative. That throws people off sometimes. All right, and this last example, we got a multiple choice, so we'll be able to see which option is right. So we're going to start by isolating. So I'm going to add 4 to both sides. So I get 7 times the 6th root of 5m plus 4 equals 14. Still working on that isolating step, so I'm going to divide both sides by 7. So 6th root of 5m plus 4. And on the right-hand side, of course, I get 2. So that's the isolation step. Next step is to raise both sides of the equation to the power of the index. So I'm going to raise both sides to the 6th power. On the left, all it does is get rid of my radical, like this. On the right, I've got 2 times 2 times 2 times 2 times 2 times 2, 6 times. That ends up being 64. Okay, so now I just solve. Subtract 4 from both sides. Lose that. I'm going to move my work up here. I've just got a 5m on the left-hand side equals 60 on the right. And divide both sides by 5. I end up with m equals 12. So that is one of my options here. Since none of my multiple choice options say no solution, that means we can be confident that the 12 actually does work out.